This is the last video on our series of rational functions, and in this case we're going to put together everything that we've learned so that we can write an equation for a rational function. Take a look at your screen. One of the first few things that you have to look for when you're writing an equation for a rational function is the asymptotes. In this case, notice that we do have vertical asymptotes, and in this picture they've given us these dotted red lines to indicate that in fact we do have these nice vertical asymptotes at x equals -1 and x is equal to 2. So I'm going to go ahead and make a note of that. Vertical asymptotes, x equals -1 and x is equal to 2. So in terms of writing our rational function, if you remember what a rational function is, it's basically a function that looks like a rational number or a fraction. So I know that I'm going to have a numerator and I'm going to have a denominator. So f of x is going to equal, and then we're going to have this in the form of a fraction. In the denominator, I'm going to put my vertical asymptotes. If there is a vertical asymptote at x equals -1, that means that one of my factors is x plus 1. If another vertical asymptote is x is equal to +2, that means x minus 2 is going to be one of my factors. The other thing that I want to notice is the behavior at these asymptotes. What is happening with the arrows? Okay, what is happening with the graph at that point? If you notice here on the very left, where I'm going over in blue, notice that around this asymptote right here, the graph is going up towards positive infinity. And right next to it, this part of the graph is also going up towards positive infinity. That tells me basically that this is the reciprocal squared function, which means that at that asymptote, x equals -1, I have to make sure that I put that squared. In the other asymptote, notice that this right here goes up, but the other arrow right around it goes down. They're going in opposite directions. So that means that that is just the reciprocal function and not the reciprocal squared function. So I'm going to leave x minus 2 without adding a second power to it. The other thing I want to look for are the x-intercepts or the zeros. So right now in my function, my zeros are wherever the graph crosses the x-axis. In this case, I have 2 zeros. So my zeros, or the x-intercepts, because they all mean the same thing, or even roots, okay? They're going to be at x is equal to -2 and x is equal to +3. Those zeros are going to go to the numerator. So vertical asymptotes, denominator, and then the zeros go up to the numerator. So in this particular case, again, if one of my zeros is x equals -2, I'm going to write x plus 2 as my factor. And if my other zero is x is equal to +3, I'm going to write x minus 3 as my factor. Now I have to check to see what is happening with those zeros. Here in this case, notice the graph crosses the x-axis, and so that means that the multiplicity is just going to be 1. In this particular case, same thing. Notice that it crosses. It doesn't touch it, it crosses. And so therefore, the multiplicity there is also 1, meaning I'm not going to put to the second power in any of these factors, okay? It's going to stay as 1. And then lastly, the only other thing that we don't know is that it could be multiplied by some factor a. We're going to call it a in this case. And in order for us to determine what would that a be, then we're going to have to use substitution. And we can substitute any point that we want. The easiest point to substitute is going to be the y-intercept. So the y-intercept here is the point 0, 3. So this is my x, this is my y. I'm going to come to this function that I've just written down, and I'm going to replace f of x with 3 because that's the y value. I'm going to keep a, and wherever I see an x, I'm going to substitute it with 0. So I'm going to substitute 0 for every x that I have, and the point is that we're trying to figure out what is that value of a, what is that leading coefficient that we possibly have in this function. So now I say 0 plus 2 is 2. This is -3 over 0 plus 1 is 1. 1 squared is 1. And then 0 minus 2 is -2. So that means 3 equals -6a over -2. If I multiply negative 2 times 3, negative 6 equals negative 6a. And if I divide by negative 6, that basically tells me that a is equal to 1. So in terms of writing the function for this problem, now that I know that I've determined that a is equal to 1, I can go ahead and write down what my actual function is going to be. So this leaves me with my final answer, which is f of x is equal to a, which is 1. So I don't really have to write it down. X plus 2 times x minus 3 all over x plus 1 squared times x minus 2. And this is going to be my final answer. Let's go ahead and try another problem. So take a look at your screen. Try to identify what the vertical asymptotes in this graph are going to be. Right here, I have a vertical asymptote at x is equal to negative 1. So my vertical asymptotes are x is equal to negative 1. The other place where it seems like I have a vertical asymptote is at x equals 2. Notice it's not x equals 1 because there is a part of the graph that crosses that. So it's actually x is equal to 2. So x is equal to 2 is my vertical asymptote. And if you remember, as I start to set up my function f of x, it's going to be a rational function, which means that it's going to look like a fraction with a numerator and denominator. The denominator is where I'm going to put my vertical asymptotes. If I have x is equal to negative 1, I'm going to write the factor as x plus 1. And then for x is equal to 2, I'm going to write x minus 2. Now I have to check to see if any of these are going to be the reciprocal squared function. And the way I do that is to look at the end behavior. What is happening around x is equal to negative 1? So here, my arrow on this left side of the asymptote is pointing up. The arrow on the right side of that vertical asymptote is pointing down. They're pointing in opposite directions. I don't have to put a square because that's going to just be the regular reciprocal function. Around x is equal to 2, which is right here, notice that my arrow goes down and the other arrow also goes down. They're both pointing towards negative infinity. That tells me that at x equals 2, it's going to be the reciprocal squared function. So at x minus 2, I'm going to have to put squared. The other thing that I'm going to look at now are going to be the zeros. So the zeros are the graph is wherever it crosses the x-axis. I have a 0 right now at x is equal to negative 2. So those are my zeros or x-intercepts or roots. So here I have x is equal to negative 2. And the other place where it crosses is x is equal to 3. Those zeros or x-intercepts belong to the numerator part of this rational function. So I'm going to write these as factors as x plus 2 and then x minus 3. And notice the behavior also at these zeros. The graph crosses at that 0 and it crosses at 3, which means that I don't have to put any of them squared. I'll go ahead and do another video on multiplicity so that you understand the difference between when the graph touches or crosses. But in this case, I don't have to worry about that. The only thing that I will have to worry about is the fact that there is a possible leading coefficient that is going to be multiplied to this function. And in order for me to find it, I need to use one point from the graph so that I can substitute. By far the easiest point to use is going to be the y-intercept. So in this case, the y-intercept is going to be the point 0, negative 2. And what I'm going to do is that I'm going to use that y-intercept and I'm going to substitute. So I'm going to replace f of x with the y value, which is negative 2. I'm going to leave a in there because that's what I'm trying to solve for. X, I'm going to replace it with 0. So wherever you see an x, go ahead and replace it with 0. And now I'm going to go ahead and do the math. So negative 2 is equal to a. This is 2 times negative 3 over 1 times, this is negative 2 squared, so it's 4. So I get negative 2 equals negative 6a over 4. Go ahead and multiply. I get negative 8 equals negative 6a. Divide by negative 6. So I'm going to get a is equal to, if I reduce 8 over 6, it's 4/3. So that tells me the value of a is equal to 4/3. And I can go ahead and write my rational function. So my final answer is going to be f of x is equal to 4/3 x plus 2 x minus 3 over x plus 1 x minus 2 squared. And this is going to be my final answer. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.